dealing with multiple motors on a single branch circuit, properly sizing the overcurrent protection device, or OCPD, is crucial. National Electrical Code Section 430.53 subsection C provides the rules for this calculation. This calculation is important to ensure the circuit is properly protected. According to 430.53 subsection C, the OCPD shall have an ampacity not less than the sum of the following two things: firstly, the full load current of the highest rated motor, and secondly, the sum of the full load currents of all other motors on the same branch circuit. Let's illustrate this with an example. Suppose there are two identical motors on the same branch circuit. Each motor is rated at 1/2 horsepower and operates at 120 volts with a full load current of 5.8 amps. First, we need to determine the conductor size. This is calculated by taking 125% of the larger motor's full load current plus the full load current of the other motor. In this example, since both motors are the same size, the calculation is 5.8 amps times 1.25 plus 5.8 amps, which equals 14.5 amps. This calculation suggests using a number 14 American wire gauge conductor, assuming the insulation temperature rating is adequate for the application and ambient temperature. Now let's determine the appropriate OCPD. Table 430.52 specifies a 250% factor for the full load current when using an inverse time circuit breaker. Since we have two motors with the same full load current, the OCPD must be rated for not less than the sum of 5.8 amps, the highest rated motor, plus 5.8 amps, the other motor, which equals 11.6 amps. However, Table 430.52 requires us to apply the 250% factor to the full load current when using an inverse time circuit breaker. Therefore, the minimum OCPD ampacity would be 11.6 amps times 2.5, which equals 29 amps. According to standard OCPD sizes, a 30 amp circuit breaker would be required. In summary, when sizing the OCPD for multiple motors on a single branch circuit, determine the sum of all motor full load currents. Then, based on the type of overcurrent protection, such as an inverse time circuit breaker, apply the appropriate percentage from Table 430.52. The OCPD must have an ampacity no less than the calculated value. In this specific case, with two 1/2 horsepower, 120 volt motors each with a full load current of 5.8 amps, a 30 amp circuit breaker is needed. Remember to always consult the latest edition of the National Electrical Code and follow all applicable local codes and regulations. Improperly sized OCPDs can lead to nuisance tripping or, more seriously, to equipment damage or fire hazards. This calculation is based on the National Electrical Code and should be verified with local electrical codes. Remember, safety is always the top priority when working with electrical systems. Always to energize circuits before working on them and use appropriate personal protective equipment. This information is for educational purposes only and should not be considered a substitute for professional electrical advice. Always consult with a qualified electrician for any electrical work.